Okay, so in this video we're going to continue to look at combination logic, where we have multiple logic gates in a circuit, and in this video we're going to focus in on the truth tables with those combination circuits and how we can write a Boolean expression from a truth table, and also how we can fill in the truth table outputs from the expression. So just kind of looking at both sides of that. Okay, so this will help us to be able to come up with a circuit, even if we don't know the specifics of maybe how an original circuit was designed or was made. We can come up with an equivalent operation for that combination circuit so that it will produce the correct logic that we need on the outputs. Okay, so first off, before we get into looking at the truth tables, just some information here. So with the truth tables, we're going to use the sum of products expression. So we're going to be writing that from the output of the truth table. So we're going to be given the output results. So we're going to be looking at the ones and zeros in the output column and then writing an expression from that. So we're going to use the sum of products, or SOP for short, expression method of doing that. Okay, so we're going to look at where all the high outputs are in the truth table, because that's all we really have to focus on for this. As long as we take care of where the high outputs are, the zeros will fall into place where they are supposed to. So we'll look at the high outputs, and then we'll look at the conditions of the inputs that give us that high output. So we'll look at the input switch conditions to see if they are low or high, and write that expression based on those conditions. Okay, and that will be written as AND logic. So we'll look at, for example, our first one will have three inputs, so we'll have A, B, and C. So it will be A times B times C for that high output. Alright, so if the input is high, then we just write the letter. Okay, so if input A is high, then we just write it as A. If the input is low, we write the letter inverted, so A naught. Okay, so here's just an example to show you how that works. So for example, if this particular output give us a high, we have A is 0, B is 1, and C is 0. So that's the combination we have to get a high output. So we would write that as A naught times B times C naught. So the naughts are where the zeros are. If we just have a 1, then we just write the letter. Okay, so for 0, 1, 0, we have A naught, B, C naught. Okay, so we'll write that out for each group, for each high output, and then we'll have several of these because there'll be multiple high outputs for each truth table, and then we will add them together. So that'll be OR logic. So each one of these is an AND function because we're multiplying, and then each group is added together. So we're basically saying A naught and B and C naught gives us a high, or whatever the next group is. Okay, and that is the sum of products because we're adding the products of each of these conditions. So that's where that comes from. Okay, so we will write one for each high output, and then that will give us the conditions that we need for all the highs, and then all the zeros we don't have to worry about, because if it doesn't have these specific conditions for each high, then that output will then be a 0. Okay, so we're going to do that first, and then after that we're going to look at basically just doing the opposite of taking the sum of products expression and filling out the truth table. So it'll just be this process in reverse. We'll look at each group, figure out if it's a 0, 1, or a 0, or whatever the combination is, and then that's where we write a 1, and we do that for each group. And then once we've completed each group, everything remaining will get a 0 for that output. Okay? So first we're going to look at writing the expression for the truth table. So in this first example, I have 3 inputs, just calling them A, B, and C, and output is Y, and then here is the results for output Y. So I have 0, 1, 1, 0, 1, 1, 0, 0. So again, I only need to focus where the high outputs are. So that's here, 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 and here. So I'm going to have 4 groups. Alright, so when I write this out, I'm just going to go ahead and write out the ABC for all 4, and then go back and put my lines. It's just easier for me to do it that way. You can certainly go one by one and do this, but I go ahead and write out how many groups I have. Alright, and then go back and look at what the conditions are. Alright, so for this first high, A is a 0, B is a 0, C is a 1. So that's low, low, high. So that'll be A naught, B naught, C for that first group. The next one, I have A is low, B is high, C is low, so that'll be A naught, B, C naught. The next one, I have 1, 0, 0, so that'll be A, B naught, C naught. And then the last one here is 1, 0, 1, so that'll be A, B naught, C. Okay? So down here, I have 4 inputs for this truth table. Again, I want to look where the highs are. So there's one there, 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 here, here, and here. Okay, so I have 6 total. So again, I'm going to go ahead and write out my groups. So A, B, C, D. And then go back and add my lines. All right, so looking at this first one, I have 0, 0, 0, 1. So that is A naught, B naught, C naught, D. So for the next one, I have 0, 1, 0, 0. So that is A naught, B, C naught, D naught. For the next one, I have 0, 1, 1, 0. So that's A naught, B, C, D naught. For the next one, I have 1 and 3 zeros, so that is A, B naught, C naught, D naught. Then I have 1, 0, 1, 1, so that is A, B naught, C, D. And then the last one here is 1, 1, 1, 0, so that is A, B, C, D naught. Okay. So again, each of these groups represent the highs. So as long as I take care of that, everything else will be a 0. So if I develop the circuit for this, I've only made up a portion of the circuit that gives me a high output. Now I can draw these out from these expressions. So I'll just do this first one up here just to kind of show you what that's going to look like. So I have A, B, and C. So I have A naught, B naught, and C. Okay, so rather than drawing out the full inverter circuit, I'm just drawing a circle on the input, and that's accepted, and that goes to an AND gate. Okay, so you can do that just to kind of save space. All right, then I have A naught, B, C naught. Then I have A, B naught, and C naught. And then I have one more combination to do here, and that is A, B naught, C. And then all four of these connect and go to an OR function. Okay, so that's the sum of products circuit from our sum of products expression. So I can do the same thing with this one down here. So, and again, you can use those circles on the input to represent the inverters just to save space in your drawing of those circuits. Okay, so we can actually build this circuit and it will give us this results. Now again, this may not be what the original circuit was, but it will give us an equivalent to make these conditions work. All right, so next we're going to look at just doing the opposite. So here we have the sum of products expression. Here we're just going to fill out the outputs of the truth table. Okay, so this is just doing the same process in reverse. So for each group here, we're going to write in a 1 for that output condition. So for the first one, S equals A naught, B naught, C naught. So that's going to be 0, 0, 0. So that's the very first one. So it gets a high. Then I have A naught, B naught, C. So that's 0, 0, 1. So that's the next one. It gets a high. So the next combination is A, B naught, C naught. So that's going to be 1, 0, 0. So that is right here. And then I have A naught, B, C naught. So that is 0, 1, 0, which is right here. And then I have A, B, C. So that's 3 ones. Okay, so that's the last one on the truth table. So once I've got through the entire expression, anything that's left over here is a 0. Okay, because remember again, the expression only represents the high outputs. Okay, so just another example here with a 4 input circuit. All right, so the first one I have T equals A naught, B naught, C, D naught. So that's 0, 0, 1, 0, and that is right here. Then I have A naught, B naught, C, D, so that's 0, 0, 1, 1, which is the next one right here. Then I have A, B, C naught, D, so that's 1, 1, 0, 1, and that is way down here. And then I have A naught, B, C, D, so that is 0, 1, 1, 1, which is right here. And then I have A naught, B, C, D naught, so that is 0, 1, 1, 0, and that is right here. All right, and then this last one says A, B, C. All right, so kind of threw this one in here to give you a little bit different part of an equation here. So basically what this is saying is that if A, B, and C are high, the output is high. So what we're saying here is that switch D doesn't matter for this state. So this actually is going to give us 2 different highs in the table. So anywhere A, B, and C are all 3 high, the output is high. So that's going to be these last 2 conditions in our truth table. 1, 1, 1. 1, 1, 1 for A, B, and C. So we don't care if D is on or off. So both of these are going to get a high. So that's what that one is telling us, is that we got 2 different conditions that give us that. Okay, so a little bit different than the rest of them, but that's what that means. Okay, so if we had just A and B, then it would be 4 different conditions that would cover. All right, so again, once we've completed this, everything else that we haven't used gets a 0. Okay, because again, that expression only covers the high outputs. Okay, so again, we can draw out an equivalent circuit from the sum of products expression and build that to give us the results that these two tables show us. All right, so that's how we use the sum of products with our truth tables to write out an expression and come up with a circuit, and also fill out the truth table from the expression. Okay, so in the next video we'll look at kind of combining all this together with a combination circuit where we write out the expression and then go gate by gate filling out the truth table to get the final results and putting all this together. Alright, so again, check out the information I got for you on Blackboard with this, and if you have any questions, let me know. Have a good day.